Hi there. This is video 1.9, and we are going to go through the steps to doing proofs, and then we're going to do a couple of mathematical proofs using deductive reasoning. All right, so steps. Generate some data to make sure you understand what's being asked for, and this is key, make sure that the question is right, because every once in a while I'll slip in ones that, there's a little mistake in there and we need to fix it before we finish the proof. Define all the variables that you're going to use. So that was from the previous video where we looked about consecutive odd, even numbers, multiples, and things like that. Okay, set up the equation and simplify, and your final statement. So how is this plan different from inductive reasoning, by the way? Inductive reasoning basically has the first step and the last step, none of the proof stuff in the middle. The sum of two odd numbers is even. So make up some data. Minimum 3. You can go more than that, but I usually suggest to have 3. So 3 plus 3 is equal to 6. Now, if you're generating numbers, don't do this. I mean, yes, that is two odd numbers, and it does come up at even, but how do you know for sure that happens all the time, or does it only happen when you do doubles? So 1 plus 9 is equal to 10. So vary it up, mix it up a little bit. 19 plus 43, and I don't know what that is. 60, 62. 19 plus 43. There we go. Okay. So I kind of did pairs, and then I did normal numbers, and I did some big ones, and we're getting even all the time. So that's a good thing. Now we need to do, we need two odd numbers. So first, let me move this a little bit closer. Odd number. And an odd number is always an even number plus 1. You can use whatever letter you want there. It doesn't matter. But it's always going to be that pattern. Now, we need another odd number, but it doesn't have anything to do with consecutive, so I need to pick a new letter. Doesn't matter what I pick as long as it's a different one. Okie dokie. So now we've got this part figured out. And we need to do sum. Oh, I guess we already established that sum means plus. So I'm going to take my first one, 2n plus 1 plus 2x plus 1, and we're going to simplify that, right? So there's the first one, there's the second one. First, okay, I'm be honest, this is the reshoot of video. The first time I put them in brackets, and then I realized the next step is I took them out of brackets. So here's my first one, here's my second one. And we're going to get 2n plus 2x. You knew that, right? You didn't end up with 4nx now, did you? No, of course not. Plus 2. Okay, we can't put anything else together. And I think the one thing that was missing from the other notes is how do you prove something's even? Oh, can you divide it by 2? So that's our test. By 2, by 2, divide by 2. So I get n plus x plus 1. And believe it or not, we just proved that it is even. So what did we do? The sum is divisible by 2, so it is even. I'm going to add a little word here. Evenly divisible by 2. There's a lot of evens in there. I guess what I'm saying is if you ended up with, hold on, grab my pencil because I'm going to write something and then I'm going to get rid of it. So say you had 2n plus 5 as a total over on this side, and then you went to go divide it by 2. Well, you get n plus 2.5, right? So whatever this is, it's not even. these numbers have to be whole numbers. So it has to be evenly divisible by 2. No decimals, no fractions. Got that? Okay, there it is. Oh, yeah, because I'm making coffee of these and I don't want to have to try and explain, have somebody try and figure out, like, why is that in the middle of nowhere? So just get rid of it. All right, the product of an odd and an even number is odd. So odd number is 3, even number is 6. Oh, it's supposed to be odd. Let's try that again. 5 and 2 is 10. 3 and 10. Okay, so you remember at the very first stage I said, bring it back. Generate some data to make sure you understand what's being asked. And then I added, or see if the question has a mistake in it. Well, clearly this one does. So let's get rid of this. You're not allowed to do that in a test or an assignment, but you are allowed to go, excuse me, can you check, is this right? And I can tell you whether it is, or thank you for discovering my mistake. All right, so we're good. Now that we've changed that, so we need, oh, again, I did it. Product, you know that's multiply, right? So we were doing that. So we need an odd number. And we got 2n plus 1. Now we need an even number, 2p. Again, the whole thing about unless you see the word consecutive, keep using new variables. So we need to multiply. All right. That looks kind of weird, but you know what? We can do it. 2n times 2p is 4np, and 1 times 2p plus 2p. Right? If you wanted to, you could have flipped that and put the 2p in the front. Same difference. You're still going to get the same answer. Now we want to prove it's even, so let's divide by 2. And we'll get np plus 2p. Oh, I get 2. 2 goes in the front. Sorry about that. 4 divided by 2 is 2. 2 divided by 2 is 1. Okay, so it divided evenly. We don't have any decimals or anything. So the product is evenly divisible by 2. So it is even. These are probably the only questions where I would like you to write a sentence at the very end. And that's it. That is how you do a proof.